Hello all, I would like to welcome you all in the lecture series of Basic Electrical Engineering. In this session, I'll be discussing the Set 2 model question paper of Basic Electrical Engineering. It is a part 3 video. Kindly request you to watch part 1 and part 2 video first so that you will be getting the continuity. Let us directly move on to the discussion of the important question from module 3. Question number 5a. With the need circuit diagram, explain the construction details of DC generator. You need to produce the need diagram. How to answer this? Do you know that? There are 8 marks. How to answer this? So, better I'll be showing you the answer key. Whenever you are mentioning the construction means what are the components it is made up of. Better you can draw a neat sketch. It carries the weightage of 2 marks. In that you have to mention about the field system and armature segment separately. So you have to give a brief explanation on the various components of field system such as pole shoes, field winding and a brief function. We do not require the entire explanation. Only the brief explanation is more than sufficient. Afterwards you have to explain the armature core and its importance, armature winding, you have to talk about lap winding and wave winding, importance of commutator, ultimately brush. If you mention very clearly, you will be getting 4 marks. And in addition to that, you have to give a brief explanation. Altogether, you can get 8 marks. Like that, we can plan the answer in an effective manner. So, question number 5b. In this question number 5b, I found some anomalies. Some data are missing. If you want, you can assume some data and you can compute. But to be frank, I could not get the proper answer due to insufficient data. However, please read. Such kind of questions are appeared. You are supposed to, if such kind of questions if you found in the question paper, try to track the important documents, important data, put down the proper equation circuit and make it in a neat manner so that you never lose the marks. A shunt generator delivers 50 kilowatts at 250 volt and 400 rpm. The armature and the shunt field resistance are 0.02 and 50 ohm respectively. Compute the speed of the machine running as a shunt motor and taking 50 kilowatts input at 250 volt. Allow 1 volt brush at contact drop. This is a question. What I did is I have drawn the circuit diagram first. Later I try to try to compute the speed. Okay, the speed of the armature. So, however, the flux is not given. That's a big headache for us. So, what I have done is I will be showing you the approach which I made out. In this circumstance, so initially better the machine will act as a generator. You can draw the simple circuit diagram of the shunt generator. Then write down the given data, compute the current through the shunt field winding. Afterwards, motor input. Then we can, by using the equation, you can compute the load current. Okay. In that you can compute the armature current because IL is equal to IA plus IS using KCL, and you know that the back EMF of a motor that can be written as V minus IR, where V is the terminal voltage. And don't forget to add the brush drop. For one brush it is 1 volt drop. There are 2 brushes, altogether it is 2 volt. EB can be computed. So, but there are lot of informations are missing, like how many what about the armature, number of conductors per parallel path in the armature, and what about the flux. If such cases you would have written one equation like EB is equal to, one equation is there, not EB is equal to 5 Zn by 60 into P by A. 5 Zn by 60 into P by A, right? So this equation you can apply and you can compute the speed, but unfortunately the sufficient data are missing. No worries, you can follow in this fashion. Question number 5c. For a single phase transformer, obtain the expression for EMF induced in either primary side and secondary side. You have to write E1 and E2. What is the equation for E1 and E2? So let us derive the particular expression. So I will be showing you that. So you have to define some parameters first of all. You have to mention about sinusoidal flux variation. From apply the Faraday's law. From the Faraday's law, you need to write the expression for EMF E. So from maximum value you are able to get. From the maximum value you need to you have to connect with the RMS value. Ultimately you will be getting E is equal to 4.44 F into 5M into N. If you want, you can write in terms of flux density and area also. That's also possible because flux density is equal to phi m divided by A. Therefore, phi m is equal to flux density into A. That is also possible. Then you have to write like E1 and E2 value ultimately. So this is a simple question. Please practice it many times. Definitely you can follow up. Let's move on to question number 6a. Please read the question. A DC motor running with a speed of n rpm obtain an expression for EMF induced in the armature winding. So you have to write the expression for EMF. Okay. So how to write the expression for back EMF? That is the question. First you write the circuit diagram. Draw the circuit. This circuit diagram says lot of information. From this circuit diagram derive the expression EB. What is EB? And in parallel you can write the expression for EB, which is connecting with the speed, flux and number of conductors, etc. And you can talk about the importance of back EMF, how the back EMF forms, how the back EMF will maintain the motor as a self-regulating machine. All the points you can able to mention. What happens if the back EMF is 0? That point also you do mention clearly and you will be getting full credits. Okay. So I will be discussing another question. Very important problem, numerical example. A 4-pole 500-volt shunt motor has 720 wave connected conductors on its armature. The full load armature current is 60 amps and the flux per pole 0.03 webers. The armature resistance is 0.2 ohm and brush contact drop is 1 volt per brush. Calculate the full load speed of the motor. First of all, please note down the given data with the relevant diagram. That is important. What I did is, I have written the given data. Please copy down this. RA, phi, Z, everything you have to note down. Brush voltage drop will be per voltage drop is 1 volt. There are 2 brushes, so I consider it as 2 volt. Then we have the formula V is equal to EB plus IARA. From this you compute the value of EB, that is 486 volt. And you know that EB is equal to 5Zn by 60 into P by A. So select the armature conductor parallel path wisely. Here the armature conductor parallel path is A is equal to 2 because it's wave winding. So that what you are supposed to do, from this expression please compute the speed of the motor. Okay, N is equal to, from this expression you can segregate the value of N and please work out once. Definitely you will understand. It carries the weightage of 3 marks. 3 plus 2, then 1. You will be getting 6 marks. So this is actually the distribution of marks. Another important question, most repeated question. With the help of diagram, explain the construction details of salient pole type and non-salient pole type synchronous generator or alternator. So how to answer this? I am going to show you how to answer this. So let me show you the, first of all, what you are supposed to do is talk about salient pole type alternator. Draw the diagram. Mention that's a projecting pole. Then poles are built up with thick steel and with suitable laminations. And you have to mention that it is having large diameter and small axial length. Mention the low speed range applications respectively. Non-salient pole alternator with a relevant diagram and mention that poles are not projecting type, and also uniform air gap between rotor and stator. It is rigid, it has small diameter and large axial length and most appropriate for high speed application. Do mention the application at the end. Any application you can mention. I have mentioned it as steam turbine. Like this you can able to mention. Let's have a discussion on 8a. An alternator running at speed of n induces an EMF in the armature conductors of the machine and obtain the expression for induced EMF. That means derive an expression for induced EMF in an alternator. First of all, you are supposed to define the parameters and weightage is given here. Then do calculate the E average. And from this you have to derive a relation. F is equal to PNS by 120. Therefore 2F can be written as PNS by 60. Therefore E average can be written as 2 phi F. Then one turn is equal to 2 conductors and T phase is the number of turns. Therefore E average can be written in terms of the TPH, turns per phase. Therefore we can convert average value into ERMS value using the form factor. Form factor is equal to RMS value by average value. Therefore RMS value is equal to 1.5 into average value. Ultimately I can consider the Kp and Kd, pitch factors and the distribution factors. Then I will be getting the ultimate answer as 4.44 F 5 T phase Kp into Kd volts. This is the